Hey, welcome back. Mr. Piels with Precal's Unit 3, Topic 4. We're once again going to deal with law of sines in the ambiguous case and also talk about word problems. So we start off with a question that's a lot like where I ended the last video because I had no time to do a question like this, which is going to have more than two triangles, and we'll talk about why. So first of all, where they're giving us angle A and side A. Now you can draw a picture of this if you wish. So you can say that this is angle A and that this is side A and that angle B, okay, so this would be 62, so this would be angle B. So we know that sine of 40 over 54 is equal to sine of B over 62. So then I would cross multiply, so it gives me 54 times sine of B equals sine of 40 times 62. I would then divide both sides by 54. That gives me sine of B equals sine of 40 times 62 over 54. And then I'll have to do inverse sine of that number. So as I do that first, so sine of 40 in parentheses times 62, divide that by 54, and here's what I've gotten so far. Now, I do know that this is going to work because I got a number that's less than 1. So if I do inverse sine of the previous answer like this, and that's going to give me about 47.56 degrees. Now, the issue with this is that this angle right here can be 47.56, or actually there's going to be two possible options here. Well, first of all, if I subtract, if I do 180, so this is angle C. Okay, so angle C is equal to 180 minus the two that I already know, which is minus 40 and plus 47.56. So let's see, 180 minus 40, enter minus 47.56 is going to give me 92.44. So that's one possible measurement of angle C. But the problem here is that we have two possible measurements because sine of anything in the first quadrant and the second quadrant are both going to be positive. So 180 minus 47.56 is going to be the exact same measurement because when this is, if let's say this is 47.56 degrees, then if I go 132, which is over here, 132 is going to give me the exact same reference angle. So angle B can also be 132.44 degrees. So that means we've actually got two triangles in this case, which kind of presents a problem. So this triangle would look more like this, and this would be 132.44. So this is going to give us all sorts of different answers. Now, first of all, C could also be 180 minus 132.44 minus the 40-degree angle for angle A. So 180 minus 132.44 plus the 40-degree angle. So this is going to tell us that C can also be 7.56 degrees. So obviously this would have to be a smaller angle up here than up here in order for this to be smaller. Okay, so if this is bigger, this is smaller. If this is smaller, then this is bigger. Okay, that makes more sense. So that's going to give us two possible answers for C. So this is C degrees. Okay, so we found C and C's alternate. We found B and B's alternate. Now we just need to find what would side C be. Now it depends on which angle you decide to use. So you could say that sine of 40 over 54 is equal to sine of angle C, so sine of 92.44 over side C. Or you could do the same thing, sine of 40 over 54 equals sine of 7.56 over C. And they're going to give you two different answers for C. Once again, it's just a matter of multiplying across and dividing by the third number. So 54 times sine of 92.44, divide that by sine of 40, and you get 83.93. 83.93. So that's what you get when you plug in the original angle C degrees. Now, what if we put in our alternate C degrees? So that would be 54 times sine of 7.56 divided by sine of 40. So that gives us 11.05. So C2 would be 11.05. So two different possible C values. Okay, so I am going to repeat a little bit from my last video because I do want to give some more examples before I get into law of cosines and show a word problem as well. And I know I'm already 5 minutes in. So law of sines is used when you have angle, angle, side. So this is an example of angle, angle, side. So we have an angle, a next given angle, and the next side. So we know that sine of 65 over x equals sine of 92 over 11. Cross multiply here. So 11 times sine of 65, divide that answer by sine of 92, and that will give your answer of x. Now, you're also going to use it when it's angle, side, angle. This is an angle, the side in between, another angle. There we go. So I would do sine of, so I could use sine of 70 over y. You can actually solve either way you want. I am going to need to find this third angle, so I need to do 180 before I can do anything else. 70 plus 62, so 180 minus 70 minus 62 more gives me 48. So that way I can set it equal to sine of 48 over 145. Now I can find side y. And then I would do the exact same thing with the other angle. So if I want to find x, I would do sine of 62 over x equals sine over 48 over 145. Cross multiply, divide by the third one, and voila. All right. Moving right along. So we need to get back to that ambiguous case. So ambiguous cases occur when it's side-side angle, as we talked about in the last video. This is a perfect illustration right here about how we have this side measurement. So you can have because this length right here is less than 6. So to make a right angle would be like 5.5. Let's just say I made that up. So therefore, you could swing this side back and forth, and you can make a triangle, because remember, this side is not, it's angle side side. This side can be as long as or as short as you would like it. So therefore, if you swing this, if you make this angle small, it'll hit right here. And if you swing this over to here, which this side is still 6, it's also going to hit right there. So we've got two possible answers for this kind of question, which is what's going to happen for all of these. Now, how do I know that the ambiguous case is occurring? Now, unfortunately, you really just kind of have to solve for it. Now, when I'm given this question, I'm just going to draw this to show you what I'm talking about. This is 50 degrees. Side L will be 26, and G is 30. All right, so now I could have put 30 on the other side, but it doesn't really matter in the end. I just like the way it illustrates this way. Now, why is this the ambiguous case? Well, first of all, notice that the opposite side is less than the adjacent side. So now, if the opposite side is longer than the adjacent side, then you just straight away know that the ambiguous case is going to occur. And that's kind of what happens over here, because no matter what direction this is going, if this opposite side is bigger, it's always going to be able to reach back and hit. So it's not going to have 0 triangles as long as the opposite side is bigger than the adjacent. Now, if you multiply 30, which is the adjacent side, times sine of 50, and you get a value that ends up being less than the other side, then you know that this is going to have 2 triangles. And I believe that's going to be the case for this. So 30, which is the adjacent side, times sine of 50, which gives us about 22.98. All right. So 22.98 is less than the 26, so therefore we know we're going to have 2 triangles in this case. Now, you might be thinking about why that might be occurring. Well, if this number happened to be bigger than 26, then keep in mind, this is what you would do with laws of sines, is you would then divide that number by the opposite side, which is 26. And if this is going to give you, let's say the 22.98 was bigger, then this is going to give you an answer that's greater than 1. And then when you do the inverse sine of that answer, obviously that's going to give you no response, because sine is limited at 1. You can never have sine of any angle be greater than 1. So this number has to be less than the opposite side in order for it to have a triangle. Otherwise, it's going to have no solutions. Same thing goes for this one. So we have angle A, which is 40 degrees. AB is 23, and BC is 28. All right, so now this time the opposite side is longer than this. And like I told you a second ago, it wouldn't matter if this was right here 179 degrees, because that angle would still be able to reach back, because as long as this side is bigger than this side, it's always going to reach back and create at least one triangle. And I would do the exact same steps and go through them to find out whether or not it has one triangle or two triangles. Now, last but not least, I want to talk about word problem. So it talks about how the angle of depression for an airplane is 22 degrees to see the Washington Monument. And then later on, after 100 miles have been traveled, then it's a 58 degree angle of depression. So that tells us quite a bit of information. So we can find how high the plane is and how far it'll have to go before it's right above the Washington Monument. Well, first of all, if I use this 58 degrees, 180 minus 58 tells me that this has to be 122. And then if I add that to the 22, that gives me 144. And 180 minus 144 gives me 36. All right, so now if this is 36 and this is a right angle because it said right above, then I should also be able to find this angle, because 90 minus 58 gives me 32. All right, so now that I have basically all the angles, I just used the sum of all angles in a triangle in order to figure that out. I should be able to now figure out these two sides. Now, I'm going to use laws of sines to find this side, and then I'm going to use my trig functions in order to find the other two sides, because I only need one side in order to figure out the other two sides using law of sines. Or in this case, I'm going to use just regular trig functions. All right, so sine of 22 is over this side right here, xy, I'm going to call this z, equals... let's see, this would be sine of 36 over 100. So this angle is across from this side. And then I can use that to find z. Z happens to be 100 times sine of 22 and divide that by sine of 36, which gives me about 63.73. Now that I know this side, then I can use my trig functions to figure out x and y. Now, this is the hypotenuse, so I could do cosine of 58 equals adjacent over hypotenuse. And then I would just multiply both sides by that denominator, so 63.73 times cosine of 58. And that gives me about 33.77. And then I've got plenty of options from here to figure out y. I could use Pythagorean theorem, or I could use sine of 58. So sine of 58 is equal to y over 63.73. And then I would once again do that calculations and find it. Now I'm going to stop right there, and I'm going to leave the last video for just law of cosines. Thanks again for watching. Have a great day.